subrings and subfields. So all of you have the idea of subgroups. So I think I don't have to again give you the idea of subrings and subfields by similar approach. So R plus dot is a ring and say F plus dot is a field. You know both the structures. Any subset of R satisfying the axioms of R, satisfying the axioms of a ring is a subring, and any subset of the field satisfying the axioms of being a field, then it will be a subfield. Very easily defined. But what is the criteria of being a subring and a subfield? You have been taught the criteria of being a subgroup. I think you know what it has to be a subgroup. Do you have to prove all the axioms to prove it to be a subgroup? No. If A and B are elements of the subgroup, you have to show that A dot B inverse belongs to the set. Then it will become a subgroup. Because by showing A dot B inverse is an element, you show all the axioms that should be there in a group. Right? So here also we have to frame such axioms. So do we have to prove everything, every axiom of a ring to show it to be a subring? No. S is a subring if and only if there are two axioms. AB belongs to S implies A minus B belongs to S. Commutative group. So group approach, that's why AB inverse. So here A minus B, because minus B is the inverse. So if whatever you have shown to be a subgroup, the same logic to be a subring with respect to plus. And with respect to dot, if it is closed, that is A dot B belongs to S. S is a subfield. S is a subfield if and only if AB belongs to S implies A minus B belongs to S. Same, and AB belongs to S implies. Now here I cannot say only closure property because every non-zero element must have an inverse. So B non-zero belongs to S implies A dot B inverse belongs to S. So same approach as subfield, okay? Because A minus B, when I am writing A, B are elements of S, that means A, B are elements of the ring also. So if A, B are elements of the ring, then closure property automatically holds, associative property automatically holds in the subring. If I am writing A minus B, that means A minus of minus A. A minus of A, that means identity element. So identity element belongs to the subring if I replace B by A itself. And A minus B means minus B is there, that means for B minus B is there, means inverse is present. So identity inverse both present. So that implies it is a subgroup, or say it is a group structure is prevailing here. Similarly here also group structure is prevailing. A dot B if I write, then I can say associative property holds, because associative property holds is inherited from that of a ring. Here also associative property is inherited from the field only. Just I have to show existence of inverse. So for any non-zero element B inverse is present, and composed with B inverse is present means unity element is present. So from there only you are generating it. So that is why subfield and subring have this type of axioms. Now if I give you a problem, how will you solve it? You will just take two elements from the set and show that these two are present, then it will become a subring. These two are present, then it will become a subfield. I will come to those type of problems in online classes. Okay, now I am just giving you one property here, that intersection of two subrings is a subring. Okay, so how will you take the property? Let S and T be two subrings. So I have to show S intersection T is also so. So let us take two elements belonging to S intersection C. What will it imply? AB belongs to S as well as AB belongs to T. Now S and T are subrings. So therefore A minus B belongs to S and A dot B belongs to S. A minus B belongs to T, A dot B belongs to T. So therefore A minus B belongs to S intersection T, A dot B belongs to S intersection C. What we come up to, that is intersection T is a subring. So very simple to prove intersection of two subrings is a subring. So with this, basically the theory part of rings fields is finished, but there are ample of problems, and I have sorted out which problems to discuss in class. You will see that the PDF material that I have already given you long back, it has so many types of problems in it. Please go through them, please practice them, and if you have any doubt regarding any problem, whether it is in the assignment, whether it is in the lecture handout, please tell me. Please email me, or you can WhatsApp me or whatever. There are several students of your class who know my WhatsApp number, so you can just take it from them, and you can just click the picture of which part of the problem you are in doubt, and you can just send it, and I will just do the problem, and I can send it to you, I can email it to you, I can voice record it to you, whatever. So feel free to give me any possible doubt, and I am always there to help you. Thank you, and signing off. I will again come back with my last lecture, that is on morphisms of groups. It's a very simple part, and because it is the last part, so I will not go to any very many details of it. I will just give you the definitions and how to do the problems. That's it. Thank you.